Hello! In this video, we'll walk through the basics of Firestore. Firestore, the Google Cloud database, is heavily used in application development platforms and low-code frameworks like Firebase, FlutterFlow, and BuildShip. However, regardless of how you're using Firestore, the underlying database concepts are similar. So, in this video, we'll be talking about concepts like Firestore databases, collections, documents, fields, and NoSQL principles. Let's get started by setting up our Firestore instance. Oftentimes, when you're working with these low-code application frameworks, they'll have ways to automatically set up Firestore for you. But regardless, Firestore is going to be running on Google Cloud, and you can actually do this setup directly there. We got a Firestore API error because this is a brand new project, and it needed just a couple more seconds to finish its setup. Alright, this looks good. Let's go ahead and create our database. We'll go with the recommended native mode. We can name this database anything, but keep in mind that the name you choose is permanent. If you're only using a single database in the project, we'd recommend the default name since client SDKs will usually default to this name. Next, we need to select a region, so we'll choose a North American, United States multi-region. We'll stick with the production rules for security reasons. Now let's go back to all databases. Note we can now create multiple databases within the same project. Not too long ago, you needed distinct projects for each database, but as you can see, this is no longer the case. Now we can discuss collections. These are separate logical stores for our Firestore documents. In addition to reviewing this theoretically, we'll dive into a real-world application to demonstrate the concept. We'll use the Cloud Shell editor and a simple demonstration application. As this spins up, let's look at the document creation interface again for a conceptual review. We're dealing with a NoSQL database here, so you have the liberty of creating documents without the need for a set schema. Quite liberating, isn't it? A schema is simply a set of rules or controls that dictate how a database's records must be structured, but again, there's no schema here. If you have a front-end development background, think about Firebase as storing JSON-like structures, albeit with a more extensive data type system. Let's illustrate. Within our reviews collection, we can have multiple documents, each with different fields. For instance, one with a rating and username, and another with a rating and a description. Different schemas, no restrictions. Running queries is when it becomes evident that our data doesn't have to conform to a schema. Here's the query builder to illustrate. Specifically, if we specify a where clause on a field that doesn't exist in a document, it'll evade our selection. Without further ado, let's build an application to further cement these concepts. We'll create a GitHub repository, and as a bonus, you'll have access to the actual code in the video description. If you're encountering an issue opening the terminal, note that browsers like Firefox may be a bit too aggressive in their tracking protection controls and blocking functional cookies. So let's turn that off and get back to the editor. Got your Python libraries? Great! Now to start creating our simple application using the Flask framework and Firebase package. These are specific application framework and client SDK choices, but note that the principles are very similar for other software. Let's start with the humble HTML page to elicit reviews from the world. Reviews will be posted in this block. Now let's run it on port 5000. In this Cloud Shell IDE environment, we can securely preview our application. Uh-oh, a tiny hiccup. A template not found error. No worries, we just need to move the HTML to a templates directory. Well, here's our simple web app. Now, the post for submitting a review is not functional yet. Let's gear up and link to our Firebase system right away. Let's create a new review submission route alongside our route for rendering the index.html. Note that we're using the Cloud Shell for an easy button approach to authentication here. When you productionalize or otherwise deploy your web application, you need to make sure that a secure authentication is maintained. Just when everything starts to get exciting, we get a DB is not defined error. Let's see how we can resolve this, shall we? Next, let's go ahead and jump back into our Cloud Shell, where we'll be confirming that aforementioned Cloud Shell authentication. We're using the logged in user to make the database connections, great for testing, but something that will need to change depending upon your specific deployment scenario. Surprise, surprise, it seems we've actually entered demonstration as the Firestore database name, while the SDK expects the default name. This is one of those immutable database properties that can't be changed. Do we update our code with some client initialization customization, or do we take the quick and easy route? Since our first database was just for a quick test and demonstration, how about we simply whip up another database, and this time name it default. We'll go down that path for simplicity's sake. Another thing to take note of, we're using the Firebase admin library here, even though we're not using much of the Firebase platform. The choice of client SDK, including programming language, is fully up to you. For example, this feat could also be achieved with the handy Google Cloud Firestore Python library. Now, let's roll up our sleeves and give this another whirl. Voila, we've successfully submitted a review. A look into our data reveals a reviews collection. So far, so good. Next up, we'll handle another leg of the journey for our app, where we fetch our hard-earned reviews, process the data, and bake it into a new reviews template. In the template, we just need to jazz up the layout with some Jinja templating for our reviewer's name and review text. Let's venture to the reviews page. John, my review, just if you need help jogging your memory, is what we submitted earlier as a review. Let's create a few more documents manually right in the database. Go ahead, put a rating here. But remember, we're now somewhat shifting the data structure. The review doesn't appear when we refresh the app. That's because our database structure doesn't mandate review text for every review, letting us run free with our design. What if we added more fields to John's review? Say, slip in a rating for good measure. Even if we tuck another field into this document in our reviews collection, if our front-end web app is not aware of or using that information, it doesn't manifest in our front end. Let's take another look by printing the JSON for our data. This is the data we're dealing with, presented in a raw, unfiltered manner. Behold one record for John's review and another one for Jane. Essentially, we can think of Firestore as a bunch of JSON files lounging around in a database, flaunting just about any structure as we earlier discovered. This flexibility means that the responsibility for input validation, data integrity, correct querying, and effective filtering rests on our application code. This has some pros and some cons, but overall tends to be a very attractive model for developers who want to develop quickly and don't have deep database administration experience. To quickly demonstrate some filtering, we could, for example, pull only reviews with actual written review text. Test this theory by heading to Reviews and hitting refresh. Voila! We only have John's review since we avoided Jane's text list review. Well, that's our grand tour of Firestore. We hope this quick introduction was enlightening. We'll keep an eye on the comment section for any questions and want to thank you for tuning in. Please enjoy responsibly.